This is possibly one of the hardest questions to ever have been asked in an exam, for Nat 5 at least. So what happens in this question is the height of the ball relative to the cliff top after t seconds is given by this equation. Now t is the number of seconds after it was kicked, and the height is relative to the cliff top. So this point is h equals 0. That point is h equals 0. Anything above this is positive, anything below this is negative. It's important that you read the question because many pupils thought that 0 height or the height equals 0 referred to this part, but it's not. So calculate the height of the ball above the cliff top after 2 seconds. Now the height above the cliff top is going to be dictated by this equation, as I said. So after 2 seconds we want to find the value of h when t is 2. So we will write h2 equals 12 times 2 minus 5. Simply substituting t for 2, and we get 24 minus, well, that's 2 squared is 4 times 5 is 20, and that equals 4 meters. So then want to state explicitly height above cliff, height above cliff after 2 seconds is 4 meters. And we're done with this part. The next part did cause a lot of issues back in 2019. So this graph, and it's a quadratic function. I maybe should have specified this at the start, but we're dealing with a quadratic, and the height is in the vertical and the time is the horizontal axis. The sea is 17 meters below the cliff top. So the sea is given by this dashed line. And we have to find after how many seconds will the ball hit the sea. So if we have a look at the equation we're given here, the height is going to be minus 17 because the sea is 17 meters below the cliff top. So h has to be minus 17. So let's write that in. So h is minus 17. And we have to find the value of t, with the value of t being the number of seconds after it was kicked. So we then can say 12t minus 5t squared equals minus 17. Now we can write this as a quadratic equation, but to do that we have to make the right hand side equal to 0. So we could add 17 to both sides, because a plus 17 will cancel out this minus 17. So we will do 12t minus 5t squared plus 17 equals 0. Now we want there to be a positive coefficient, i.e. a positive number in front of the t squared. So let's multiply everything by minus 1 to get rid of this negative. Multiplying the 0 by minus 1 will keep us at 0. So let's multiply by minus 1 and we get 5t squared. Then we get minus 12t and minus 17. Now the way we do this is we have 5t squared. So we have, I will do this in purple, we have 5t and t multiply by each other to make 5t squared. So what we have to do is we have to then write down all numbers that multiply to make minus 17, all combinations such that one is positive and one is negative. So all pairs of numbers that make minus 17. So for example, you've got minus 1 and you've got 17. You've then got 1 and minus 17. You've then got 17 and minus 1. And you've got minus 17 and 1. One has to be positive and one has to be negative. But because these are not the same, each combination is unique. So you see that the minus 1 and 17 and the minus 1 and the 17, now these two might appear to be the same, but in this case the minus 1 multiplies the 5t, and in this case the minus 1 multiplies the t. So the idea is we have to multiply these and add up such that we get minus 12t. So let's give this a go then. So 5t times minus 1 is minus 5t. T times 17 is 17t. 17t minus 5t is 12t, which is not minus 12t. So it can't be those. 5t times 1 is 5t. T times minus 17 is minus 7t. And 5t add minus 17t is minus 12t. Now, this is the one we want. Minus 12t. Now, we then have to do this. So the idea is that these two are in the same bracket and these two are in the same bracket. So you don't put the 5t and the 1 in the same bracket. We consider this one, and you put the opposites. So you've got 5t and minus 17. So we do 5t minus 17. And you get t and 1 if you cross them over. And we then solve this. We get two solutions. So either 5t minus 17 equals 0 or t plus 1 equals 0. So in this case, t equals, well, 5t equals 17, so t is 17 over 5, which equals 3.4, or t equals minus 1. And we're told after how many seconds will the ball hit the sea. Now it makes logical sense that it has to hit the sea after it was kicked. A, because the graph only includes the information after it was kicked, but also the ball was on the cliff top, so it doesn't make much sense for the ball to be in the sea, then go up to the cliff top. Doesn't make much sense. So t has to be greater than 0. So we say t is greater than 0, and we have to discard t equals minus 1. So discard t equals minus 1. So we say that it hits the sea after 3.4 seconds, because that's the only solution that makes sense in this case. And we underline all of this to make clear that's the official final answer. So this was just solving quadratic equations, albeit in a fairly unseen situation. But let's have a look at, I should really put meters in there. So let's have a look at how the SQA gave the marks out. Well, the first mark is you either got it or you didn't, and it was for the 4 meters. The first mark in section B, or the second mark of the whole question, was given for this. The third mark, or the second in part B, was for that. So we got that. The fourth mark would be for factorising. And the last mark would be for solving and eliminating t equals minus 1. Getting that would be the last of the 5 marks in the entire question. Now they don't accept guess and check, so you can't just mess around with the numbers and substitute values of t in. You have to actually solve the equation either this way, or you can use the quadratic formula, would also work in this case. But using the quadratic formula would be a lot harder to do, especially without a calculator. And if you show no working, you would get no marks, because they're assessing your ability to solve a quadratic equation and show the steps. So I hope you found this video useful, and best of luck with the studying. Thank you for watching.